Hello. So we're going to talk about Git, and I'm actually using a book from it's a publisher company called Book Apart. It's called Git for Humans. These books are pretty inexpensive, and I have several of them in my library. The ebook is $14, and I'll be sharing this with you guys. So we're going to talk about Git. As she says, Git is infuriating. It's critical in two very different and equally compelling ways. So practically, Git is a prereq for collaboration on websites, which if you're holding this book is something that we do. So while you don't love Git, you have to know it. Many Git tutorials bend over backwards to map Git's arcane practices to real-world phenomena, often leaving readers hanging from trees, wondering which branch is about to snap. But then let's see, Git's going on. I'm not going to read everything on this. So it talks about when we first started making websites in 95, all you had was HTML. But now we have HTML, CSS, and JavaScript. That's evolved from languages from crafting documents, simple enough for most designers could write out from memory, to something that's a lot more complex. We have the power to make truly amazing things for our users, things we would never imagine what the web was young, but the cost of feeling like gerbils running on a technology treadmill. So now's the time to come clean. GitHub is confusing. Git is confusing-er. Pretty much everything in a modern web stack no longer makes sense to me, and no one explains it well, because they assume I know some fundamental piece of information that everyone takes for granted and no one documented, almost as if there was a secret that sped around to most everyone sometime in 2012, yet I somehow missed because, life was happening. So I've just given up on trying to understand even the parts where I try to comprehend what everyone else is working on that warrants that kind of complexity. And now I fear that this makes me irrelevant. So I nestle close to my story, that my value is my ideas and capability to make sense of things, even though I can't make sense of the above. But really, maybe I'm doing okay since it's all too much to know. Let the kids have it. Okay. So Git is hardly the most complicated new web tech, but it's part of a new stack of all parts of the stack have in common. You cannot escape Git if you want to participate in any kind of new platformy web. At some point, you'll need to contend with it. There's plenty of books, blog posts, and stuff. Yet, despite the wealth of tutorials, some days it feels like you can't turn around without bumping into someone complaining that Git makes no sense, and yet we use it. Let's see. Git is difficult in part because it embodies what somebody called a leaky abstraction. Abstractions in the software sense are things that make a task conceptually easier to handle by covering up elements that make them hard. Interfaces are abstractions. There's absolutely no relationship between dragging a file to a trash can icon to delete it and actually removing the file from your hard drive, except the designer thought it would make the concept of deleting files easy to understand. And it works. Even though I used computers for more than a decade without knowing how the shift key worked, I never had trouble understanding how to get rid of a file. Abstractions are there to protect us from complexity. A leaky abstraction fails at its job by letting some of the underlying complexity peek through, the same way a leaky umbrella fails as the job of keeping you dry. Let's see. Git's interface is leaky because its command line interface fails to protect you, the user, from knowing how it works under the hood. And one reason why Git is so scary is that it has its own internal logic, but doesn't always map to how we humans are used to organizing information. So knowing how it works is sometimes essential to getting it to work. To use Git successfully, you sometimes need to be able to apply Git logic to situations where human logic fails. In other words, to master Git, you have to think like Git. Let's see. Let's get started. So in yesterday's video, whenever we download it, I don't have it up. Whenever you downloaded the latest source release, I should have downloaded Git Bash. Let's see. Yes. Okay. It should have downloaded Git Bash. You may or may not have saved it to your taskbar. What all Git Bash is it's just like command line. It's just the interface. It's just the command CLI command line interface. That's very similar to this right here, which you may be more familiar with. I believe that this is more, the bash is more in mind for the Linux, those who are familiar with a Linux operating system. And obviously this is Windows. So, and they work pretty similar. There are some differences in the commands that you can give for it to work. And bash has that $sign, and where Windows does not. So that's just one of the differences. Let's see. Let's go ahead and close, minimize this, both of those. So if you've been around for a while, you may recall it was once common for authors to carve their words into stone, leaving aside the stamina that's required. Basically, you're making changes to work once it was completed. It was inconvenient to do that. Fixing a typo, let alone clarifying one's message, or making the language flow better required cutting away sections. So over the centuries, it became easier to put things in writing, which in turn made it easier for writers to explore different approaches. But until the introduction of computers, the best way to record or distribute an idea was still to put it on a piece of paper. So many of us still think this way in how we produce our work, taking the time to clarify and improve something over the course of multiple drafts. When I was in school, a few teachers attempted to show me and my fellow students the value of iteration, which basically means doing things again and again. Not to mention starting projects earlier than the night before they were due, but asking us to turn in not only our final papers, but also the drafts before them. Let's see. But there are at least two areas of our written culture where making incremental changes and tracking those changes across multiple versions is not just helpful but crucial. Which is law, okay, and software source code. Like other kinds of writing, source code went through what might be called an analog phase. Early computers had to be programmed by punching holes into cards, which were fed individually into the machines. Early coders endured some of the same problems that early writers did. Making changes on physical media is expensive and time consuming. Computing languages had to be understood by machines, which remain much stupider than we are. Elements of version control. So what they came up with was a version control system. The basic principle of a version control is this. Instead of keeping only the latest copy of something, you hold on to each successive revision as you work. So you might refer or revert back to an older version if you need to. Although you can use software tools, one of which is the subject of this book, to help you, version control is more importantly a practice. Many of us have projects where we kept copies of old versions of our work, using the save as command. Version control systems like Git work by keeping a copy of each successive version of your project in something called a repository, into which you commit versions of your work and to represent logical pauses like points in a video game. Every commit includes helpful metadata like the name and email address of the person who made it, so you can pinpoint whom to praise or blame for a particular change. Those commits are called branches. Let's see. So some of the terminology that we've come across so far are commit, repository, and branches. These commits are organized into branches, each representing an evolutionary track in your project's history, with one branch, the trunk, or a master branch. Let's see, which represents the official primary version. So having built up a history of past commits, it's easy to retrieve a previously committed version of your project, roll back any changes, or compare two or more versions to aid in debugging. In order to save changes to your repo, there needs to be one version of this project that you can safely make changes to. Version control systems like Git usually call this the working copy. Its job is to act as a scratch pad for any changes you may want to make to the project. You'll eventually commit these changes to a repo as an official saved version. Let's see. Version control can be laborious because it is a regular desktop workflow. We're expected to save changes to our work twice, once to the working copy and then also to the repo. Let's see. I'm not going to read this whole book. So talking about these days, sharing files such as our store of committed versions is the easy part. Your repository can be a shared folder on a service like a Dropbox or Google Drive, or a networked hard drive or a file server in your office. Inviting a new collaborator to your project can be as simple as granting them access to a folder. Where things get tricky is not simply in syncing changes between teammates, but coordinating those changes so that your version control system remains trustworthy and viable. The system of numbered version directories and working copies may seem straightforward, but you can never assume that two people will interpret or follow simple rules the same way. So to sustain a trustworthy system, it's essential that the rules always be followed in exactly the same way. Let's see. For the sake of argument, though, let's suppose that everyone on your team understands the rules and that any member of the team can reliably commit a new version. So what happens is what do you do when they happen at the same time? The difficulty here doesn't involve following the rules so much as communication. Once we reach the point where two collaborators might need to work with the same files at the same time, run the risk of one person's changes overriding another person's work. So imagine you and I are collaborating on a website. You're exploring what it would be like if we change all the links on the site from red to green, where I am considering changing the link color to blue. Under the rules of our version control system, I should make and save my changes to the copy of the style sheet file in the directory. Unfortunately, the rules also say you should make your changes in the exact same place. Following this method, whether the links are going to be green or red, the next numbered version of the project depends entirely on which of us made our change last. If I saved my file later than you saved your file, my changes win. The only way to avoid this clobbering is for individuals interested in submitting changes around the same time, you and me in this case, to work together to make sure that either our changes don't conflict or that our version control system somehow automatically reconciles or rejects conflicting changes. Some primitive version control systems solve this problem by requiring people to check out a file, like a book from the library. So checking a file out marks it as uneditable by anyone else, and the person who checked it out has both finished editing and explicitly checked it back in. This addresses the risk of the unintended file clobbering, but also creates a new problem. If I'm on the one with the homepage file checked out, you're stuck waiting on me to finish before you can do your work. So we have distributed collaboration. Instead of having one working copy shared by everyone, we require all team members to make their own working copies stored on their own computers. In theory, at least, this allows each of us to work independently until it's time to save a new official version. There's still a small risk of two people trying to commit versions at the same time, but that happens less frequently than just saving changes while working. And we can coordinate those kinds of changes. Say, hey, I'm going to push version 34 of the website. Everyone cool with that? By email or something like Slack. With this system, we haven't done anything different to try to merge together different versions with different changes into a cohesive whole. Rather, we're making named copies of folders and assuming that our working copy is a trustworthy canonical source for this next version. The next big problem is to solve what happens when that stops being true and our working copies drift out of sync. In the diagram, your version, let's see right here. In the diagram, your version of the site now has green hyperlinks, while my copy has blue links, and the latest official copy, version 12, has red. Both working copies are newer than the shared master copy. That's the master, these are the working. But beyond that, how can we know which colors the link should be in the official version? More importantly, how can we know what else might have changed? What if in addition to the changed link color, your copy of the website includes a lovely new page explaining the company's mission, and mine has a fix for an annoying JavaScript bug? This is where the homegrown version control system completely breaks down. It's not that we can't work together to combine our two working copies into a single version. It's that doing so takes up valuable time we'd much rather spend writing, designing, doing something else. Auditing our own work files for conflicting changes is no fun. More importantly, it doesn't scale. As we add more files, more collaborators, and more changes, the risk of accidentally introducing major problems increases. So remember that version control is much more than just versions. It's the rules and processing for managing versions. Once you have a lot of files, a lot of collaborators, or both, it can be exhausting to enforce those rules without a referee. So fortunately, all these things, enforcing rules, keeping track of versions and repos, passwords, shelling changes back and forth, and so on, are done by computers a lot faster and better than we can. By learning and adopting an automated version control system like Git, we can keep our work neatly organized and our changes safely coordinated with one another, all without a lot of effort that is once we adopt and learn how to such a system. So Git does for version control what web standards have done for our code, for that matter, Microsoft Word has done for word processing documents. Let's see. Git excels at synchronizing changes because they're between different computers, whether servers like GitHub or your laptops. Members of your team can use Git to combine efforts on a project, pushing changes to a central hub where collaborators can pull down their own copies or review work in progress. Git's way of staging changes and managing branches gives you unparalleled control and flexibility over how changes to your projects are committed and organized. These attributes make Git perfect for projects like Linux operating system. Let's see. So Git works your project in a local repo. It's usually on a hidden folder in your hard drive. Let's see. These server-based processes are centralized in the sense that the only place you can get your whole history of prior version is accessible, and only your working copy is accessible offline. Git is a decentralized version control system. Both your working copy and your complete copy of your entire history of the project reside on your computer, the server, and every other computer that hosts a copy of the project. By default, Git's hidden repo folders live inside a visible working copy folder. If you browse that directory, you only see files and folders you expect to see in a working copy of your project. Let's see. So that's kind of a brief explanation of what Git is and the purpose of it. So what you have here is like you have your master. File. And if you have, let's see, what I want to do here. And if you have person A, and then person B, okay, wanting to make changes. So say, for example, person A is going to be working on HTML. Excuse me. And person B is going to be working on CSS. Okay, what happens though is, like, you know, instead of them having to, like this book is referring, say person A checks out the master copy of the file. Without version control, person B would have to wait until person A is done with it. So let's see. Okay. Inline or internal. Let's say they're going to be doing CSS internal. Okay. Or embedded. Okay. So if they're working on master copy of a, let's see. So somebody's person A's got HTML file, and person B, they're wanting to work on CSS, but they're wanting to do it in the same file as the HTML instead of an external. You know, what they can do is they can both pull the file. So let's say the file name is index.html. Okay, with version control, they can both pull, or they can fork it. Fork the file. And this might be a GitHub terminology, forking it. And then whenever they make some changes, so let's see, makes changes. Okay, they can do a pull request. So they're requesting the master, whoever maintains, like, let's see, they can do a pull request. So there's somebody who maintains this master copy. There's somebody in charge of this. So what they can do is do a pull request, and then using GitHub here as an example, GitHub will see if there's conflicts. And then, let's see, I'm getting ahead of the book here. So let's just stop right there. So there's a master copy of the file. Person A can request it. Person B can request it. They request it by forking it. both persons make changes, and then they do a pull request, which is basically asking the master copy to pull in their changes. And I've already gotten ahead of the book, so let's just stop there. It says so if you're learning Git recommends sticking with the command line. I don't know if we're going to do that. Might just stick with GitHub. So the Git development team maintains an easy-to-use installer package for Windows. This is if you do the command. If we're going to do the command line, you can download from the official Git website. Install Wizard will ask you a bunch of questions, and then you just do it. So this is I think I downloaded the wrong one. Oops. I don't know if that makes a difference or not. I don't know. Okay, so this is what Git Bash looks like now. This is green. Mine's not. Let's see. So let's look at this a little bit. Let's do Git help. And when you type in Git help, you can see all the different commands that are available. If you do a command in Windows, it is help maybe. Yeah. So, and what that does is gives you all the commands that you can do. CD is the one that I probably do the most. To display the name over changes of your current directory. I believe, I don't know, CD. Yeah, CD is the same, I believe, for Git Bash. Okay. So by default, however, the Git installer provides its own terminal application called Git Bash, which is what this is, which emulates Unix-based systems such as OS X or Linux with support for not just Git, but all the commands we'll be using in this chapter. If you're custom using Git in one of these platforms, or if you're the most consistent command line experience across different computers, you can use Git Bash. So although Windows and Linux both support the same encodings for plain text files, they use different line endings, that is, different characters for denoting line breaks. Many Windows or cross-platform text editors, including Atom, Sublime, already do a good job of handling line endings correctly, but Git may not always know which format it should use. So one of the small differences, while Windows paths use backslashes and drive letters, Unix paths use forward slashes. An equivalent path on my Mac would be da-da-da. Okay, so I have both my command line and Git Bash open. Okay. And let's see. So if we do dir and Git Bash, it gives me a directory of what the file I am in right now, over the folder where I'm in right now. I don't even know what it is. Let's see what this is. dir for, nope, that's not what I wanted to do. So that gave me a lot of stuff. I think I was looking for this. Nope. Nope. Maybe it was dir. Okay. Let's just go ahead and put it in our C drive. So in Git Bash, you can just type in cd C colon, and it's going to take us to our C drive. And you can do the same thing with Windows. cd C colon, cd C. What is it? What's going on? That's not what I want to do. Let's try CD desktop. Oh, I'm already in the C drive. Duh. Okay. Okay, so there's all the folders it was finding. I want to go back a little bit. CD. Trying to remember how to go back. Okay. Okay. That's where I want to be. So now if I type in dir for the directory of the C drive, it comes up with that. And I do dir for bash, it comes up with something similar. And then if I do cd users, same thing here, cd users, and then dir cd pinwheel t31810 dir, and let's see, let's get off to speed here. cd pinwheel t31810 dir. So you can see how they're very similar whenever they're pulling up the files, folders from each. I think this might actually pull up individual files, or this pulls up folders. I'm not 100% certain. But that's how you can kind of navigate using either or. So let's see. If this is your first time interacting with the command line, entering weird bits of jargon after a prompt may seem scary unless you're a programmer. It's understandable. The command line is a little scary. Your computer will let you do things from a command line that it might stop you from doing a finder control panel. Keep in mind, however, that although the command line is powerful on another level, it's a little stupid. The command line is a holdover from an era from a fully graphical operating system like Windows and operating in OS X. Were powerful enough to govern every aspect of a computer. Let's see. First, you have to think you want to do a computer as a language. First, you type the thing you want the computer to do in a language it understands. Then you hit enter to submit the command. In this case, we've stumped the computer. In this case, we've typed the name of another program we want the shell to run for us. Okay, so let's go back into this. I've not done this, so I don't know how this is going to work. Who am I? Oh, that's cool. After that, it'll print the prompt changes again. Command line programs often lack ceremony. They'll print out the information you ask for, but won't try to very hard to make it pretty. Although many commands, including several gits, can be almost too chatty with the responses, who am I is terse. So we're going to make a directory. And we're going to name it, let's just keep name. What do I want to do? That says JavaScript, but because we're an HTML class, let's just make a directory called HTML. So there was nothing that came back, but if we do that, try to make that directory again, it's going to say it already exists. So if we hit dir, you should see HTML, which is the directory we just made. In this case, let's see. The terminal, like a single Finder window on a Mac, is always looking for a single active directory or folder. So we can do that using this change directory command. So cd, let's see. This is called the working directory. You can find your current location in an absolute path using pwd. So pwd tells me on my C drive users panel folder. So we can change that to, I'll change it to HTML, the folder we just created. Look in folder, there should barely be anything in there. There's not. So then we do pwd, present working directory. We're in our C drive users panel HTML. Says one handy tip to remember: if this is your first experience with the terminal, you can use a tilde character and pass as an alias for your home directory. I'm not going to worry about that. To keep things simple, the command prompts used for the remainder of the book will look like this, which is similar to what ours looks like. Or will look like, if not yet. Okay. Then the current Git branch, in this case, master is listed in parentheses. Later on, we'll explore other branches, but master is a branch we'll be working on this chapter and the next. So now that we know how to navigate the terminal, it's time to start interacting with Git by sending it commands. So the command name is the example of one of over 100 individual functions that Git can perform. Through some Git functions work with just a command name, like Git status must require some parameters to know how to do their jobs. You can do a lot of Git commands as a kind of sentence. Git, please do that other thing. Da, 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 da. Okay, configuring it. We have git config global user name Tasha Penwell and git config global user email Penwell T31810 at hawking.edu. Here we're telling Git that a particular configuration property of username should be set to the value that we've provided. The global option tells Git to set these values as a default for all projects on the computer. You can use git config command to set configurations options. The global option tells Git that these values as a default for all projects in this computer. You can, if you want to, use the git config command to set configuration options like username within specific projects by taking out the global. Let's see, starting a new project. So let's make dir our website. Yeah, let's do our website. So creates a folder named our website, and we can see that by typing in dir, and you'll see our name of our website is the only one that's in that folder. We change it by going to our website, and if we can look at present working directory, it says that we are in our website, and you can also see that right here. So let's initialize a new Git repo within this new project folder using git init. So we got a fresh new empty Git project on our computer. It's empty in the sense has no files yet. So if you're not the person responsible for initiating your projects, more likely have your first step upon joining a Git project will be pull down a copy of the repo stored on a server somewhere. It's called cloning. Let's see, let's pull this back up. Cloning a repo is a sequential process that Git helpfully wraps in a single command. Git clone. Let's see. So we're back in Bash and go git clone. Type this in tps git for humans.info.
Good morning, arts, business, and sciences. Hi. Okay.
Let's just copy that. Oh, copy, paste.
Okay. Okay. Will do. You guys take care, call if you need me, and whatever happens, let me know. Bye-bye.
Let's find another one. Let's go to GitHub. Wes, boss. Let's see. That's not what I want. Let's do. Okay, let's go to Wes Boss's website. Yeah, JavaScript 30. My account. So this is my personal account with Wes Boss. You would create your own account. So this is what I was looking for. So let's do let's do finished. I think going too far ahead. Clone, that's what I'm looking for. So we can copy that, go into our bash, and git clone. Pasting on here is different. There we go. So let's see, directory. So we have JavaScript 30 in there now. I'm gonna copy this.
Oh my God, there's good stuff. Good morning. What are you doing? I am reading about some aspects.
Okay. Where's my book? There's my book. Okay. So the clone we just created comes with a full history of the repo, including every change shared by every other copy. So what if we go ahead and say the JavaScript 30. So you can see all the individual files. We do a comparison to some degree. 30 Wacamo. Yep, okay. So we can see all the individual files from 1 to 30, and then the pull request template in the README file, which was in the GitHub. Let's see. I'm trying to remember how to open it from VS Code.
Not sure what's how you hear it.
It's not that, I don't think. I'm gonna do it from here. Let's see where I'm at. I was gonna go ahead and open up Git Bash and VS Code. Thought I'd try that. Code. Maybe I didn't try it. Oh, I did CD. Okay, so give it a minute and it'll open up in VS Code. And in here, you can see all the files that that were in his WesBoss's repository. You can play with it. You can do whatever you want with it. You can make it your own. So this is one of the concepts of open source. Now, since we're not working on a project with WesBoss, there's probably not going to be any kind of request where you're going to do a pull request or anything of that nature. So this is like one concept of utilizing Git and for your personal projects. So that's where I'm going to stop this video at.